Good afternoon and welcome to the week 8 live interactive session for the problem solving NPTEL course Transition Metal Organometallic Chemistry Principle to Application. So in this course we have already completed the weeks up to week 7. Now week 8 will be over in this course after this session. So far we have discussed so many things. Like in the last session we have started discussing our transition metal carbon bonded to a carbon, that is the carbon where sp2 hybridized, that is carbon, or that aryl transition metal aryl group, aryl complex. So and after discussing, we have discussed the some properties of the transition metal carbon complexes, their reactivity, and after that we move to another important topic, that is the transition metal carbine complex. So today's series of questions will be mostly discussed on transition metal carbine species, their formation, their reactivity, their properties and their reactivities. So as like the carbene, transition metal carbine is transition metal bonded to the carbon atom where carbon is sp hybridized. That means it is a linear and carbon is bonded to the metal where three bond, that is triply bonded. So out of which one is the pi bonded and another two, one is sigma bonded and another two is the pi bonded. So with that I will explain that their synthesis and properties and reaction through the help of 10 questions. So I will wait for a few minutes to get the participant to connect. After that we will start the discussion through the question and answer session. I will wait for 5 or 2-3 minutes to have anybody, otherwise I will start the session after 2 minutes. So this is the PDF of the lecture series, which is also available in the portal where you solve the assignment or ask your questions. So with that I will help, this PDF will help you to use this as a note for all the lectures. So as you can see, this week discussion is fully on the system of metal carbine, their properties, synthesis properties and reactivities. So as this is, we are going to properties and reactivities, so most of the questions will be reaction type, that is the what will be from in this reaction. So after the end of this question series, I will point it out some important reactions which I have not discussed in this series, but I will pointing out from this PDF so that and explain that reaction so that you get an overall idea of this week content. That is the all 5 lecture will be summarized. Okay, so let's start the today's series of discussion of carbine chemistry with their synthesis properties and reactions. If anyone has any doubt, unmute and ask. Okay, still now nobody is there. If anybody join, we'll see it later. Okay, so let's start the presentation. So welcome again to the week 8 live interactive problem solving session for the transition metal organometallic chemistry principles to application. So our first question is the nature of carbonic carbon in Fischer type carbene complex is. Okay. So nature of carbene carbon is. So as we have seen that the difference between the transition metal, so transition metal bonded to C, that is the carbon, and R, where this transition metal and carbon via one sigma bond to pi bond. So this carbon is sp hybridized and has 3 electrons donated to the metal. So depending on the synthesis, or better to say that depending on the spin state of carbonic carbon, we can determine whether it is a Fischer type carbene or it is a Schoch type carbene. So as all of you know that the carbene is generated from the corresponding carbene complexes. So if the corresponding carbene complexes is a Fischer type carbene, so the corresponding carbene will also be a Fischer type. So for the Fischer type, this carbene carbon is should be so as for the carbene system we discuss their naming Fischer or Schoch depending on the substituent on the carbonic carbon. But here as we have only one substituent, so we cannot do that. So but we can do the naming from the corresponding carbene complexes by looking at the property. So when if the carbonic carbon is holds the positive charge, that is the delta positive charge, and that means it acts as a electrophile and it undergo attack by a nucleophile. So that time, like the similar Fischer carbene complex, we called is a Fischer type carbene complex. So here also the term Fischer type carbene and Schoch type carbene not coming for the substituent but from the properties. Also from the spin state we can differentiate. The Fischer type carbene, the spin state is doublet spin state. Doublet spin state. So we called is a Fischer type carbene. How this spin state is coming, we will discuss later of this question answer series. So here for the Fischer type carbene, it will be as an electrophile, and as it is an electrophile, it always undergo the nucleophilic attack. So option A and option D is the right answer for this question. Next question is predict the product of the reaction. So, in this lecture series, that is this 36 to 40, you will see a couple of reactions. Where we used the PME3 as a reagent. So this question for this is a very important question for exam point of view. Okay, so the group PME3, we can say that it is a strong sigma donating group. Strong sigma donating group, and the carbene attached to the metal center is carbene is strong pi acceptor. So you can say that the pi acceptance property, so strong pi acceptor, and it is stronger than CO. Okay, so the pi acceptance property of the carbene is stronger than the CO. So what will happen when the carbene is there? When the carbene is there, that so carbene is there. Carbene is there, it try to have a strong sigma donating group to balance the electron density on the metal center. So for that, most of the reaction you can see it happen in presence of PME3 or strong phosphorus donating ligand. So here what will happen? So one of the CO will migrate to this carbene carbon, and this thing will attach to this. Okay, so one of the CO will migrate to this and two of the PME3 will attach to this. So this option number C will be right answer. So we have in option number C two PME3 group, two PME3 group, two PME3 group which provide a strong sigma donating and is provide the thing like this. So option number C will be the right answer for this question. Okay, so this is the right answer for this question. The next question is the predict the product of the reactions. Here also you can see another group like C5H5 and also this moiety carbene complex is there. So here if you have the generate can generate two question out of this. So what is this? So here we have a carbene complex, carbene complex with trans halide ligand, trans halide ligand. So what will happen? So if you have another ligand Y, so this will undergo substitution this chloride. So if you have the C5H5 kind of a ligand, so what it will do? It will substitute the CO because trans ligand and this carbene has strong 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 trans effect. So because of that it can substitute the Cl. Even the trans effect is so strong that it can substitute the CO also. So for that reason the options, so here the C5H5 is getting attached to the metal center, but here there is no C5H5 in option number D. So first all, like as I told earlier, by looking at the options you can just cut down one option, that is not possible. So this option number D is not possible. So between A, B and C, just check the validity of 18 electron rule. You know that the 18 electron rule complexes will provide the maximum stability. So because of the maximum stability we can say for this complex will have the maximum stability, and the alkyl moiety bound to this alkyl moiety, this moiety will not undergo the substitution. Okay, so from these we can say that here there is no carbene species involved, so this is also not possible. Here the carbene species, the carbonic carbon is undergo the chloride substitution, which is also not possible. So correct answer is option number A. So option number A is the correct answer. Also see that these complex satisfy the 18 electron or 18 valence electron rule. So how? So chromium has D5, D6, D6 electronic configuration, to having 6 electron plus 2 carbonyl group will give 4 electron plus cyclopentadienyl Cp will provide 5 and carbene will provide 3. So total is 18 electron, which is satisfying for this complex. So here also just applying the thing of concept, you can get the correct answer for the question. So in this question we have seen two different things. One is the carbene moiety attached to the metal center have strong, shows or displays the strong trans effect. It can substitute the trans ligand, that is Y. So it can substitute the trans ligand Cl to any other ligand Y, and this that attached alkyl group to the carbonic carbon will not undergo the easily substitution, where because of the strong trans effect this chloride can also undergo the substitution, as well as the CO carbonyl group can also undergo the substitution reaction. So option number A will be the right answer for this question. Another thing that while choosing an answer, some general concept of 18 electron rule should be maintained. But as I told earlier also, that 18 electron rule cannot predict the stability alone. So other factor should also considered. Next question is the carbonic carbon atom in a Fischer type carbene complex is. So that means transition metal bind to Cr, where this is a Fischer type complex. So now to answer this question I already say in the first question that for Fischer type of carbonic complex, this carbon atom is electrophilic and undergo the attack by a nucleophile. So this is sp hybridized and it has s and px hybrid orbital to participate. So another py and pz orbital is vacant. So with that the 3 electron is hosted. It can be carbon. So if the 3 electron on this carbonic is hosted like this, that means it has one unpaired electron, one unpaired electron, one unpaired electron. So what will happen? One unpaired electron this we can calculate the spin state. So it will be 2 into n I plus 1. So we have 2 into n hour equals to 1, I equals to our spin is, so this is half minus half plus half, so spin is half, so half plus 1, so that is 1 plus 1 which gives you 2, and the s equals to 2 suggests that doublet spin state. So it will be doublet spin state. Now we have to check the hybridization also. So for hybridization, we all know that the carbonic carbon is sp hybridized. So for that our correct answer will be option number B. It is a doublet spin state and sp hybridized. So Fischer carbene is in a doublet spin state and sp hybridized. Next question is between the carbene and the CO ligand. So carbene between the carbene and the CO ligand, option A, carbene has a greater pi accepting character. Carbonyl CO has a greater pi accepting character. Both the carbene and CO are of equal pi accepting character, and both the carbene and CO can bind in a non-linear fashion. So as I have already said this to the previous previous question, that carbene is carbene is very strong pi accepting ligand, and it is stronger than CO. So carbene is a very strong pi accepting ligand and it is stronger than CO. So which option will be correct? So option A, that is the carbene has greater pi accepting character compared to CO. So option A will be the right answer for this question. The next question is, this is another very important question. They predict the product of the reaction. So this is a carbene complex. Carbene, not carbine, having a phosphorus group which is reaction with a electron withdrawing ethylene moiety. That means you can say it is an activated ethylene or activated alkene moiety. alkene moiety. So what will be that product for this reaction? 40 degree centigrade 6 hour reaction time. This is another very important reaction. Okay, so this reaction you can see that we have a phosphorus group, and this phosphorus group P is a star. Why it is star? Because it attached to three different moiety, three different groups. So this center is chiral center. So this center is a chiral center. So because of this chiral center, what will happen? This complex act as a carbene transfer carbene transfer agent. So this carbene in transferring to a olefin to synthesize cyclopropane ring. The important thing is to note here that because of the chiral phosphine ligand, not only is transferred its carbene but also transferred it chirally. That means only one isomer formed selectively over the other. So the presence of chiral moiety in the carbene transfer catalyst or carbene transfer compound complex provide only a single isomer and does not produce the mixture of an enantiomer. So this is very important. So here there is no formation in these two questions. A option no cyclopropane ring. So option C and option D is totally wrong. But in option A and option B, the thing is totally same. CO2 ET in above side and CO2 ET is downside. So you can say that here the ethylene CO2 ETO2 group, that is the ester group, is in a trans fashion. So here in product this should also be in a trans fashion, but because of the chirality induced by this group, the major product of this only will be the option number B, that is the OMe will be the above side and pH will be the downside, not the above one. So this option A and B just the two enantiomer, but because of the chirality on the phosphine center, it will only generate the one product, that is enantiomeric pure this product. So this complex, as I said, not only transfer the carbene center to form a cyclopropane ring, but it also transfer the chirality information to give the enantioselective product. Question 7 is predict the product of the reaction. So this is the methyl lithium. In presence of methyl lithium, what will happen? So here the methyl lithium, so it will be Li plus and Me will be minus. So what will happen here? So as because of this center will act as a electrophilic center. So what will happen? This will attack to this and one of the double bond will be open up to, so because of this one of the bond will open up to metal, that is manganese, its excess positive charge will be satisfied. So this positive charge will be neutralized by this, and this will attack. So this will transfer to a carbene complex. So Mn Cp double bond C Me Me CO CO. So if you don't see the substituent, here the methyl, and here it is the CO and CO. So if you don't see the substituent, you will end up with the wrong answer like this A. But actual answer, because CO will not substitute in presence of methyl lithium, it will substitute only attacked at that carbene center and from this. So option number B will be the right answer, not option number A. And this will not be happen. Okay. So option B will be the right answer for this question. And here it is a electronically neutral complex. Here it is charge. Because of this charge, you can say that it is a Fisher type carbene center which undergo the nucleophilic attack to generate this complex. Question number 8 is, this is a very important, another important reagent question. We will discuss it after this question. So Tebbe's reagent is an alternative to. So what is Tebbe's reagent? Cp2 TiCl2. So this is called the Tebbe's reagent. So what it does in presence of trimethyl aluminum, it turn the reaction. So the Tebbe's reaction is performed through it from the metal carbene complex, and this carbene is transferred to the carbonyl like the Wittig reaction. Like PH3P plus CH2 minus, this will transfer to Wittig. So here also the metal carbene is transferred to this carbonyl. So we get the, if you have carbonyl double bond, so we will get this CH2 like this. This is an alternative of Wittig reagent. Question number 9 is another very important question. So this reaction was a scientific serendipity to discover metal carbine. Because of this reaction was performed by which they discovered the metal carbine species. Before that, carbine was only a theoretical concept. It was not existed in the bench. So initially for this complex, when react with BCl3, like you can write this BCl Cl Cl. Now this compound, you can say that boron. Okay. So boron, because of this, what will happen? We can. The idea was this oxygen have a lone pairs of electron, and boron has vacant orbital. So what we will do? This vacant orbital with created takes up the electron from the oxygen. So boron acts as a Lewis acid. And this chloride will be eliminated as Cl minus. So Cl minus will again attack to this carbon and this will eliminate it. Okay, I think it is clear. So what will happen? So C double bond Cr, Cr double bond C O Me, Me, and we have, let's say, Cl2 B Cl. So what will happen? This will undergo this boron and this will liberated Cl2. Now this Cl2 will attack to this and leave this. So it will generate Cr double bond C Cl M. This was the idea for this reaction. But unfortunately or fortunately, whatever, the thing did not happen in this way. This was the planned reaction. We can say that this is a planned reaction. This plan was made to have this compound. But what happened? This compound not formed in the reaction medium, but this chloride atom, instead of attacking to this carbonyl carbon, a carbonic carbon, it attacks to the metal center and remove this. So because of this, the extra electron was transferred to the vacant p orbital of the carbonic carbon, to generate the carbine. So this is the serendipity which was accidental discovered the metal carbine species. So here that OCH3 act as a good leaving group but the complex right answer will be option number B. So metal carbine species. Metal carbine species. And the last question is the carbonic carbon in a shock type carbine complex is. For Fischer type, we have already seen that. See, for the Fischer type, we have already seen that it is sp, as it is triply bonded, so it is sp hybridized, and the electron in spx, py and pz in these three orbital undergo can house these three electron. So what will happen here? So what will happen here? So here it is a shock type carbene. So for shock type carbene, transition metal Cr. So what will be the property? Property will be, this will be nucleophilic and undergo the electrophilic attack. This is a property wise, and for hybridization wise, as I drawn C this, and you have this and 1, 2 and 3. So that has 3 unpaired electron. Now if you put this in the previous formula as 2Ni plus 1, so what will happen? So 2 into N, N means here N equals to 1, so 1, because we have only considering 1, into I is, so 3 unpaired electron. So half plus half plus half equal to 3 by 2. 3 by 2 plus 1. So 2 and 2 undergo. Remaining is 3 plus 1 equals to 4, and S equals to 4, that is the spin state, describes the quartet spin state. So for shock type of carbine complexes have quartet spin state, and it is also sp hybridized. So with the 10 question we have discussed the how metal carbine was discovered, what is the electrophilic and nucleophilic property of both fissure and shock type of carbide complex, and another important property is the carbine is strong pi acceptor ligand, even it is stronger than the carbonyl moiety. So in most of the carbine complexes, metal carbine complexes, some strong sigma donating ligand like the trimethyl phosphine kind of ligand is required to stabilize it, and the carbine can also, in a suitable condition, can carbine complex, if there is a CO, it undergo the CO migration to the carbene to generate the C double bond O, like this kind of species. So with this I completed the 10 question which was close related, and I believe it covered most of the important topic of this week content. So after this I will go through that PDF in last 10-15 minutes, and 10-15 minutes, and I will try to show up another important points which can be remembered for this part of or this week topic for the final exams. If you have any doubt, you can unmute and you can ask. If you have any doubt. So this session is for problem discussion session. The problems which is closely related to that particular week. So today we discuss the week 8 topic, and the problem was also prepared on that particular week only. If you have any suggestion for this series of problem solving session or doubt, you can ask, or otherwise I will continue to explain some important topics from that lecture PDFs. You can unmute and ask, or you can write your doubt on the chat box also.
No, sir, no doubt.
Okay, then let's continue that thing from that PDF. So in this, I again summarize the thing. So in this week 8 we have completed the two important topic of this lecture series, that is metal carbene complexes and the metal carbene complexes. So particularly, so in this week we completed the properties and reactions of metal carbene complexes, particularly Fischer carbene complexes. Little bit more about the short carbene complexes is still remaining, which we will discuss in the subsequent weeks. So carbene, so before going to the carbene, just point out these iron complexes with phenyl with phosphine ligands. So there are some carbene complexes which undergo the carbene transfer agent, or is called as a source carbene transfer reagent, which undergo the which transfer the carbene to an olefin to synthesize the cyclopropane compound, which is highly sterically demanding and difficult to synthesize. So by in this carbene transfer method we can synthesize that, but this example is also not very popular. So after that we have discussed this question, that when we have a chiral moiety present in the complex, so this complex not only transfer the carbene moiety to this olefin, but also transfer the chirality to this cyclopropane ring. So only one isomer is formed. And another thing to note, that this CO2 group is was in trans orientation. So when it formed the cyclopropane ring, it is also in the trans fashion. That is, one group is on the above side and one is the below side. This carbene moiety, so some in presence of internal alkyne, when is present in a internal alkyne, reacts with internal alkyne, it undergo the aromatization, and from the naphthalene kind of, or substituted, better to say substituted naphthalene moiety, which is bound to the metal, in a pi fashion by removing one or two CO moiety. After that we move to the our famous reagent, that is the carbene complexes. As this is transferring the carbene, so like the Wittig reagent, like these complexes, this CH2 PH2C, this carbene moiety can react with a carbonyl group to generate the olefin, like the Wittig reaction. So this complex can undergo the Wittig types of reaction to generate the olefins. This is a similar type of questions, or similar type of another example. So after this we have that discuss the how the metal carbine was generated. So this is the T-base reagent Cp2TiCl4 in presence of aluminium Al2Me6 in toluene. It breaks Me2AlCl and minus CH4 methane, and it forms these carbene complexes which again react with the carbonyl group to give this Wittig product. So so instead of the phosphonium ylide complexes, this Tebes reagent is an alternative to Wittig reagent which can undergo which can transfer the carbonyl to olefin. So this reaction which I am discussing the last, so planned reaction was to synthesize this moiety, but we ended up having a new type of organometallic compound, that is serendipitously to have the metal carbine species in 1973 by Fischer. So substitution occurred trans to this. And here also one thing to remember, that carbine ligand has unusual pi accepting property, and the pi acceptance is more than the CO. Now we look for the reactivity of these complexes or the properties of these complexes. So here this tantalum complex in presence of PME3. So one thing to note or one thing to explain here, as I already mentioned, that the carbine complexes or the generation of carbine species, there is a role of this phosphorus group, that is the PME3 or some phosphorus or strong sigma donating group. Why? Because this because of this PME3 group, is a strong sigma donating group, and because of this PME3 group, it will can strongly donate the sigma electron, for which the strong pi accepting the carbonyl ligand can be stabilized over the metal center. So most of the reaction in the next few reaction will also see the involvement of that PME3 or any other phosphorus ligands. Here also you can see that DMP also dimethyl phosphinoethane. So DMP is this ligand which donates the electron in a strong sigma bonding ligand to the tantalum. This example is another good example or the thing to remember in the exam. These undergo the metastasis reaction, that is it breaks the metal bond and these acetylene bond and form a metastasis product, which was also discovered by Schork in 1982. here we have another one complex or one good example of complex where both like transition metal alkene, transition metal alkyl, and transition metal alkyl, carbene and carbine both exist. So this is a structurally characterized complex. This is a structurally characterized complex where you can see that the that both existence of both alkyl group, that carbene moiety and the carbine moiety. So from this bond distance you can see that the metal alkyl bond distance is about 225 pm, whereas metal carbene bond distance is 194 pm and metal carbine bond distance is about 175 pm. So with this you can rationalize the fact that when the common fact that when we increase the bond order like the single bond to double bond to triple bond, the bond distance drastically decreases. So this is the example of the carbene complexes where three different types of ligand is existing. So this is the orbital picture of carbene complexes where we have seen that for the Fischer type of carbene, the 3 electron out of which 2 is localized in a paired fashion of sp(x) hybridized orbital, whereas another electron remains unhybridized. But for the soft type of carbine complex carbine, that all the 3 electron remain unpaired electron, one in sp(x), another is py, another is pz. So because of this, the Fischer type carbene act as a doublet spin state, whereas the soft type carbene act as a quartet spin state. So this is the similar thing which is different from the metal carbene metal carbene compound. And the last example, we have also seen that because of the strong pi accepting property of this carbine moiety, it provides a strong trans effect. So any trans ligand like X can be eliminated by another strong trans ligand like Y to give the similar kind of complex. Or if you have another ligand like the C5H5 cyclobutadiene ligand, so it will eliminates the trans ligand as well as the CO to give to generate this product. And one thing, this compound we have seen this manganese example also. So this the electron reactivity of carbine is higher. So what will happen this? So when a carbine is reacting with a nucleophile, because of the electronegative nature of the carbonic carbon, it will undergo the nucleophilic attack, and carbine complexes undergo the transformation of carbene complexes. So this is a reversible formation of carbene and carbine species. When for this case, if a PME3 group is attached to this, it may also undergo the reductive dimerization process. So with this, I think we have concluded, and this example also we have discussed that in the C-C coupling reaction, that is the migration of one of the carbonyl group to the carbine moiety to generate the C double bond O ketyl or ketenyl type of system. So this is all for this week content, I think this week content is very much interesting we compared to the carbene and the properties of the carbine. So I think no more thing is remain to explain. So I will wait for another 5 or 10 minutes to join or to have the participant. If anybody have any doubt, after that I will leave. If you have any kind of doubt regarding this course or regarding the assignments or anything for the chemistry perspective, you can ask. Or if you have any kind of suggestion for this uh, live problem solving session, that also you can share.
Hello, sir.
Yes,
Sir, how many questions will be asked in the final exam, sir? The final exam is of 100 marks. So whether the questions are 100 or 50 questions for final mark?
that I am not sure. I will explain. 1 minute. Let me stop presenting. 1 minute. Final question, right?
Yes, sir. Yes, sir.
Hmm. I think there will be 100 question. 100 question.
Sir, whether there is negative marking or no?
Negative marking. There will be 100 question, that's for sure. And if you like for MSQ type, if you do that partial marking is also there. Like if the two answer is there, if you write get one, that is also possible, I think. Okay, so and negative marking, I think we don't have negative marking. I am not sure, you just ask in the portal.
I have seen the information on the portal, but there is no information like
Yeah,
this.
there is a discussion forum, right? You know,
Yes, sir.
a discussion forum. So this is an exam related question. So if I say something wrong, so if the rule have changed now, so there will be difficult. So for this technical question, you better to ask on the discussion forum, and you get the answer from there for the technical type
Okay.
of question.
Okay, okay, sir.
Anything you require from that chemistry or course perspective, that I can discuss here. Because every year the rule little changes little bit.
Okay, sir. Thank you, sir.
Exam is on 26th August, is 26th October.
Yes, sir.
Okay, so we have already completed the 8 week, 9 week content is also live. So, and that most of that. So one thing I can, for exam, one thing to say this, you have to remember that equations, that is the reactions, that means the properties of the system very thoroughly, otherwise you will not able to get the, not able to write and get the right answer of the question. It is MCQ and the mix of MSQ. I think there will be a guideline that some one part of the question will be mixture of MSQ and MCQ question, and for MCQ question I think that there is a partial marking. I am not sure. Negative marking may be there. I am that I also know, do have no idea. So because you change, you ask this on the, that you are on the discussion thing. So that team will answer that whether it is whether the negative marking is there or not, whether there will be separate portion of MSQ or not, or that question will be like the NET exam, whether a question will be divided in three part A, part B, part C, like that or not, or everything will combine together. So these types of technical question please ask in the forum, and there will be a record of final answer, and everybody can see the answer also.
Sir, is there any link for old question papers?
No, old question paper has no link. So like you can see that there is some video, I think, for the last year assignments, so that you can go through, or like that I am uploading all the questions here, so that question you go through that, and everything is from based on this course topic, previous year, previous than previous, like this. So everything is combined here, huh? So you go through the portal assignment and the question which I am discussing. So you don't need to see the video also, like recorded. Just there is a Google Drive link. I think you are getting through the email. So you just go to the link. So by every week I am uploading 10 or 11 questions that you can solve. Okay. So that will maybe help you for that better, or you have an idea what kind of question can be asked. So I generally say you that it is better you do practice the reactions and try to understand the reactions, because the exam will be more on reaction based question and less on theory based question. Theory will be used in the reaction to answer the question. Direct theory based question will be less, because that the pattern has changed from last year. Or any other question you have?
Yeah, hello sir. Actually, sorry to say, like I joined a bit late because there was some network issues, and also I woke up a bit late, so that's why I couldn't attend.
That's fine. There will be a recording sheet, recording from the drive link, so you can go through that and let me know if you have any doubt on that. So okay, or if you
Okay,
have
sir. Okay.
so if you have any doubt from this assignment or that content of this week, you can just share.
Sir, could you please share the screen? Like I just want to see the questions.
No, I have already discussed. It is
Okay, sir.
5:30, and I have already discussed all this, and this recording sheet will be there. Okay, so this whatever I have discussed today, there will be a recording sheet, and through that sheet you can access the video and you watch it. If you and you can also go to the drive. Go to the drive and to get that question. This types of recording sheet you will get, right? So here I will upload the week 8 content, that is the today's video, and then this is the drive link. So you get this from the email because link is same, and watch this. And if you have any, so after 1 or 2 hours I will upload this by today night, and then you watch it, and if you have any doubt after that, just let me know in the next session. Next session will be on the same time.
Yes, sir.
Okay. Today's
Yes, sir.
session was very easy. That is, we have discussed transition metal carbine complexes.
Carbines. Ah, yes, sir. Carbines. Okay, sir.
Carbine complexes, how they have synthesized, how they have made, and in the starting, and after that we have discussed their properties, their fire accepting property, donor property, their electrophilic property, and after that we have discussed some of the reactions.
Yes, sir. Okay, sir.
Reaction, that is how nucleophilic substitution happen, how this happen like this. So this is very easy, and the spin state of metal carbine species, where
Yes, sir.
for the carbine we have seen it is a singlet or triplet, for the carbine it is doublet and quartet, because carbine has three electron. Fisher
Like three bonds,
three bonds, so three electron.
sigma, pi, and delta.
Hmm. Three bonds, three electrons. So because of the presence of three electron, two different orientation is possible, and that's why you'll having the doublet and quartet.
Yes, sir. Like both Fisher and Shaw carbene can make a carbine.
Hmm.
It is just an electron. Like for Fisher carbene, like electron must be rich. Then only it can form this bomb,
Hmm.
triple bond.
Hmm.
Yes, sir. Okay,
Okay.
fine, sir. Also, sir, I'm just like learning for this organometallic chemistry throughout this whole week. Like now, I've reached till this catalysis. Also, I'm solving like problems as well,
Hmm.
like questions. I'm able to solve questions. Like in the class itself, they're telling us to solve questions.
Yes.
So through that, I'm just attending all these questions and then classes as well.
Hmm. Okay.
The class actually it is like textbook super coaching. This is that platform where
Yes.
I'm
Yes.
learning.
Yes. Yes. So solve the question. First solve the previous year question, and after
Yes, sir.
that solve the new question, which from that question test series is called test series. So from that
Yes,
you
sir.
will get the answer.
Yes, sir. Sure.
Yeah. Okay then. Okay
Yes,
then.
sir. Also, sir, one more thing is like I'm learning this. Recently, I'm learning these reactions and all, like one migration, one insertion, 1,2 insertion, beta hydrate, oxidative addition, reductive elimination, then metal olefin complex, and hydrate acceptor protonation reactions and all. I'm learning
Yes.
thoroughly.
Yes. So organometallic complex, organometallic chemistry is not not a small chapter. It's a very big chapter.
Yes,
So
sir.
it will take time. The organometallic coordination chemistry. These are the two very big chapter in
Yes, sir.
inorganic chemistry.
Yes, sir. From these only the questions will be coming mostly. Okay, sir.
Organometallic and coordination.
Okay, sir. I'm learning all the things.
Hmm.
Like I like whatever syllabus I've learning so far, that syllabus is only getting applied in this course.
Hmm.
Okay, sir. Fine.
Course, this course content not too much oriented for the competitive exam, but it focus on a particular topic or
Yes.
some particular region of organometallic chemistry.
Yes, sir.
But for competitive exam, you need a greater region to answer some different types of question.
Okay, sir.
Okay.
Yes, sir.
Okay then. See you in the next next Sunday. That is
Yes, sir.
21.
Yes, sir. Sir, total how many more weeks will be coming? Like till week it has been uploaded.
It is a 12-week course.
12. Okay, sir.
12. So 12 session, and there will be one hour or 1.5 hour session, which will be like eh, the feedback session if you have any doubt after this. So 12-week means each week I am discussing 10 question. So 12
Okay.
week means 12 into 10, 120 question minimum. So you
Okay,
as
sir.
portal have 120 question, and I am also writing 120 question which is different from the portal.
Okay, sir.
So for this whole course you are having 240 question
Yes, sir.
before your exam.
Yes,
So
sir.
what can be other than this? So if you
Right.
solve the 240 question, so it is or understand the concept behind these 240 question, it is not difficult to qualify the exam.
Yes, sir.
What is the difficulty is some react question will be based on the different reactions.
Yes,
So
sir.
because of the different reaction, different exception, that is difficult to remember.
Yes, sir.
Okay.
Yes, sir. Okay, sir.
So you see this recording
Hmm.
from that YouTube, and and get the question from the Google Drive link, and after that still if you have any doubt, or you think that this part should be made a little bit improved, so we'll discuss in the next. So
Yes, sir.
completed the 8 week, so 9, 10, 11, 12, 4 more series will be there, and there will be one series which will be extra.
Okay, sir.
So to get the feedback and to summarize the overall topic, overall content,
Yeah. Okay, sir.
what we have learned in from this course, that will be that
Yes, sir. Sure.
from that series. Okay then, see you in the
Okay, sir.
next day. Thank you.
Thank you, sir. I'm sorry, sir. Like today
No,
this
no,
didn't
that's
happen.
fine.
Okay, sir.
That's why I am recording now.
Yes, sir.
So if everybody, so only one or two will join. But recording may see the whoever wants to anytime you can see this.
Yes, sir. Sure.
Okay. Okay
Okay,
then.
sir.
See you in the
Good day,
next.
sir. Thank you very much.